come back to the original node number 3. Therefore this one is another one loop. This is loop number 2, right? See here, another one loop is here. Here signal starts at node number 6, it reaches node number 7, right? And it can take this path once again to reach the node number 6. So this is also another one loop. So there are totally 3 individual loops are there. There are totally 3 individual loops are there. So I am drawing these individual loops separately, right? You just see these diagrams, right? Starting from node number 3, it reaches node number 4. Starting from node number 3, reaches node number 4. The gain here is G2, and it comes back to the original node number 3 with a gain of minus H1, right? This is what this loop number 1, right? 3 to 4 with a forward gain G2, reverse gain minus H1, right? So this is your first loop. The next loop is, it starts from loop 3, right? Reaches loop number 4, node number 4, then reaches, it goes to node number 5. So it takes 5 to 3 in this direction with a gain of reverse gain of minus H2. Understood? This is another one loop. Here the branch gain is G2 and this branch gain is G3, right? This is what the second loop in this diagram, right? This is what the second loop. 3 to 4, 4 to 5, 5 to 3. Understood? This is a closed loop. So we have drawn this loop separately, right? What is another loop? The final loop. See here, starts from 6, 7 reaches 6. Okay, so I am drawing this loop once again. See here, 6, node number 6 reaches node number 7. The forward gain is G5, and it once again reaches node number 6 with a loop gain of minus H3, minus H3. Now you can write the individual loop gain. How to write the individual loop gain? So the already we have given the names as here. For forward path we have written it as P1, P2, etc. Therefore you need to write the individual loop gain as P11, right? Individual loop gain as P11. P11 is equal to this loop gain, right? A minus sign is there, therefore minus G2H1, minus G2H1. This is what your first forward loop gain. Next one is the P21, right? The second individual loop gain is P21, which is equal to P21 is minus sign is there, so minus G2 G3 H2, G2 G3 H2, right? Minus G2 G3 H2. Next one is the P31, third loop gain. This is minus G5 H3, G5 H3, right? These are the individual loop gains. Okay, these are the individual loop gains. Next, you need to find the gain product of the two non-touching loops. You need to find the gain product of the two non-touching loops. Gain product of two non-touching loops. Okay, see here in the original diagram, right? So in the original problem, so I am showing you the problem also. You need to find the gain product of the two non-touching loops, the two loops which are not touched together, right? You see here, this is a loop, right? Loop number 1. See here, loop number 2. These two are touching loops. Understood? These two are touching loops because this gain branch is common to both the loops. Therefore these two are touching loops. These two are not non-touching loops. See here, this loop G1 and G5 are non-touching loops, right? G1 and this loop number 1 and this loop number 3 are non-touching. These are not touching each other. Similarly, this 2 and this 3, these two are not touching each other. Therefore the two non-touching loops are, the first one is the, see here, the first one is this loop, right? That starts from node number 3, reaches node number 4, right, with a forward gain of G2 and a reverse gain of minus h1, right? And this loop is not touching with this one, right? That is node number 6, node number 7, node number 7. So this gain is g5 and the reverse gain is minus h3, minus h3. Understood? So these two are two non-touching loops, right? Similarly, you are having another one pair, that is the first loop and the third loop, second loop and the third loop. What is the second loop? Node number 3, right? You can see this diagram also, right? Node number 3, then node number 4, node number 5, right? This gain is g2 and this gain is g3, right? So the reverse gain is minus h2. This is not touching with the last loop. Last loop is node number 6, right? Node number 7, 6 to node number 7 with a forward gain of g5 and a feedback gain of minus h3, right? These two are not touching. Similarly, these two are not touching. So these are the combination of two non-touching loops. Now let us write the gain product of the first combination of the first combination of the two non-touching loops. This can be written as P12. This can be written as P12. That is nothing but this is individual loop gain is P11, isn't it? P11, and for this loop the individual loop gain is P31, right? So this is nothing but gain product only, right? So P11 already you have written this P11, right? What is that? This is the P11, right? This one is the P11. P31 is this one. So you have to take the product of these two gains, right? That is minus G2 H1 into minus G5 H3, minus G5 H3, which is equal to G2 G5 H1 H3, right? This is the answer, right? Similarly, for the next combination, gain product of these two things, this can be written as P22, right? P22 is equal to P21, right? P21 into P31, right? What is P21? P21 is equal to minus this one, minus G2 G3 H2 into, right, P31 is minus G5 H3, minus G5 H3. What is the resultant, which is equal to G2 G3 G5 H2 H3. This is what your answer, right? This is what your P22, right? Now you have found the gain product of two non-touching loops, right? Now let us see, is there any three loops which are not touching with each other? See here, this is the first loop, this is touching with this one, right? But it is not touching with this one. Therefore these two are two non-touching loops, combination of two non-touching loops. But these three loops are not individual loops. Suppose if the three loops are not touching with each other, then you need to take the gain product of such loops also, right? Gain product of such loops, right? Gain product of three non-touching loops. But here in this case it is not like that, right? There is no, because these two loops are touching each other, and therefore there is no such three non-touching loop combination is there in this problem, right? Now let us see the calculation of delta, right? We need to calculate the delta function. Okay, how to calculate the delta? The formula to calculate delta is equal to 1 minus the forward path gain P11 plus sum of the gain product of forward path gain P11 plus P21 plus P31, right? Next, plus the sum of the all possible combinations of this is the formula, right? Sum of all possible combinations of two non-touching loops, right? So here the two non-touching loops are P12 plus P22, P12 plus P22, right? Next, minus three non-touching loop. So there is no three non-touching loops, so we are ending the formula with these two things, right? Now you substitute all these values here, which is equal to 1 minus P11, the forward path gain. Already you have written this forward path gain P1 and P2, right? So here the individual lobes, right? Sorry, P11 means the individual lobes, right? Delta is equal to 1 minus sum of individual lobes plus sum of gain product of all possible combination of two non-touching lobes. Therefore, what are the individual lobe gains? These three are the individual lobe gains, right? Now you can write 1 minus P11 is nothing but minus G2 into H1 minus G2 into G3 into H2 minus G5 into H3 minus G5 into H3 plus P12 and P22. So P12 and P22 already you have taken the gain product of this one, right? P12 and P22 you have written. So these two values you need to add. Therefore it will become G2 G5 H1 H5 plus G2 G3 G5 H2 H3, right? This is what the answer. Now you can simplify this, right? You can simplify this, you will get one answer. Next delta 1 and delta 2 you need to calculate. So that the final value of the delta will be equal to this one. You will get, after simplifying that equation, you will get delta as, which is equal to 1 plus G2 H1 plus G2 G3 H1 H2, right, plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3, right? Now you calculate delta 1. Delta 1 is equal to 1 because there is no part of the graph which is not touching with the first forward path. Delta 1 represents the part of the graph which is touches with the there is the part of the graph which is not touching with the first forward path. There is no such things. Therefore delta 1 is equal to 1, and delta 2 is equal to for the first forward path, because you see here this is your first forward path, right? This forward path is touching with all the entire diagram, entire system, right? This forward path is touching with the entire system, understood? But here you delta 2, you see P1, you just see P11, right? P11 means this lobe, understood? This lobe, the part of the graph which is not touching with the second forward path. You see the second forward path, this is the second forward path, but this loop is available at this place. Therefore this part of the graph is not touching with the second forward path. Therefore we can write delta 2 is equal to 1 minus P11, which is equal to 1 minus G2 into H1, which is equal to 1 plus G2 into H1. Now you need to find the transfer function T, which is equal to 1 by delta into summation k pk into delta k, summation k pk into delta k. So now you have calculated delta, you have calculated pk delta k, that is equal to, which is equal to 1 by delta into P1 delta 1 plus P2 delta 2, understood? P1 delta 1 plus P2 delta 2. So you are having the value to this, all these things, right? This is forward path gain 1, this is forward path gain 2. Delta 1, delta 2 you have calculated here. Now you substitute these values. Delta also you have calculated, so that you will get the answer as G2 G4 G5 into G1 G3 plus G6 divided by G2 plus G6 H1, right? The total divided by 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5, H2, H3. This is what your final answer, but you need to substitute all these things here, right? So thank you.